Skip prompt and pray JSON. Use Azure OpenAI structured outputs with a strict schema. That one choice turns a flaky extractor into a reliable pipeline. This is for engineers turning PDFs and docs into a knowledge graph. Structured outputs guarantee schema-valid JSON with zero parse retries. We cover three things: the extraction contract, the API choice, and the graph store. One of them hides a gotcha that silently corrupts your graph. Stay for the entity resolution trap. Start by defining what a good extraction looks like. A knowledge graph is nodes and typed edges. Model both as Pydantic classes, entities with a type, and relationships. Constrain entity types with an enum, not free text. Free text types explode into synonyms and rec queries later. Give every entity a canonical name field. This contract becomes the schema you hand the model. There are three ways to get JSON from the model: free-form prompting, legacy function calling, and structured outputs. Free-form means you parse text and pray it's valid. Function calling validates loosely but still drifts from your schema. Structured outputs in strict mode rejects any non-conforming token. Use a PI version 2024-1120 or later. It refuses to emit fields your schema never declared. Here is the extraction call in Python. Pass your Pydantic class as the response format. The parse helper deserializes straight into a typed object. No regex, no JSON.loads, no cleanup. Send one chunk of document text per call. You get back entities and relationships you can trust. Here is the gotcha I promised. Each chunk extracts entities independently. The same company appears as three different node IDs. Your graph fractures into disconnected islands. Fix it with an entity resolution pass after extraction. Normalize names, then merge by embedding similarity or a canonical key. Overlap chunks by 10 to 15% to preserve cross-sentence relations. Never skip the dedup pass. Here is how the pieces wire together on Azure. Documents land in blob storage. Azure AI Document Intelligence parses layout and text. A worker in container apps chunks and orchestrates. Azure OpenAI returns structured graph fragments per chunk. After resolution, you persist nodes and edges into your store. Where do you store the graph? For native traversals, Cosmos DB Gremlin API scales globally with low ops. For rich graph algorithms and Cypher, run Neo4j yourself. If your main need is retrieval, skip both. Store nodes in Azure AI Search with vector fields. Rule of thumb: choose by query pattern, not hype. Traversal heavy picks a graph database. Search heavy picks AI search. Recap the decision framework. Define a strict Pydantic contract with enum types. Use structured outputs, not prompt parsing. Always run an entity resolution pass before writing. Pick the store by query pattern, not popularity. Pricing and API versions shift, so check the current Azure docs. Try it on one document set this week. If this helped, do me a favor, hit the like button, subscribe, and tap the bell so you don't miss the next one. See you in the next video.